Hello wonderful person, this is Anton, and in this video we're going to be doing a little bit of science and try to use a concept known as gas collapse, or gas collapse theory that is, to try to see if we can create some sort of a very large, very massive object, but more specifically a star. We're going to use gas simulation to try to recreate the formation of a solar system. It's going to be much smaller than our own solar system, obviously, and it's just going to be a simulation using a model, but let's see if we can do it. Welcome to What the Math. Now this right here is actually a momentum or collapse momentum simulation from Universe Sandbox that uses different types of, I guess, planets. I think that's just Mars actually. Yeah, just different types of Marses to try to collapse them all into one large object. But what I wanted to do is see if we can recreate early formation of the solar system using something similar but a much sort of larger object. Specifically, what we're going to be doing is we're going to try to recreate our own sun. So let's start by maybe placing a very, very small object right in the middle, just so we can use it as a source of formation. We're going to remove it right after though. And here what we're going to do is we're going to create rings. This is essentially how you can recreate this yourself. Let's say we're going to create approximately 200 different bodies, and their total mass is going to be just a little bit more massive than our sun. So maybe about 150% of the mass of the sun. Now, the reason I'm doing it this way is because I wanted to basically create a star much faster than it would otherwise. Now we're going to simulate this as if this was basically gas particles, but at the same time, it's not going to be particles, but instead it's going to be basically these very, very large objects. So let's do it the following way. We're going to place them at a distance of maybe a few thousand kilometers to a few hundred lunar distances, and it's all going to be in the shape of a box with random distance or random spacing. And for the most part, oh, and we also want them to be not moving. So for the most part, I think we're done. We're going to see if this worked. Let's place them and let's see what all of this looks like. This is going to be our first attempt because I wanted to try it with just objects first before we try it with basically gas. So right now we've created this kind of a cube-like object where we have basically like 200 different moons. Each of them is about 7.8 masses of Jupiter. Now, if I let this go, you'll see that at some point they'll start collapsing. And this is what gas collapse theory basically states, that if you place mass, no matter how far away it is from any kind of distance, it will start collapsing into a single point somewhere in the middle. And that point usually results in the formation of a star. And this is kind of what we're trying to create here. Let's see if we can basically turn these objects into a very massive central point. So notice how overall all of them seem to be slowly approaching the center. Their vector is pointing toward the center because that's kind of where most of the mass is. And this is very interesting because no matter how many times you run the simulation, they all converge toward the center. And within a few seconds now, they're going to most likely start colliding all in the middle and basically start creating larger and larger objects. Now, there's a really interesting way of seeing this as a chart, where you can kind of see how basically all of these objects are colliding with each other, and they're slowly becoming more and more massive on this side. And eventually there's going to be a lot less objects, and many of them will basically become part of something else. So here, if I remove trails, you'll see that there's a lot of interaction in the middle, and a lot of these objects start orbiting around each other within this sort of area, or I guess volume. Their orbits, on the other hand, are completely crazy. Like, there's a lot of insanity going on here, and it will take quite some time before all of this stabilizes. So I actually will remove trails for now because I want to see how all of this plays out. So let's actually make it run for, I guess, a few in-game days. And let's see what happens. So you can kind of see that initial collision is kind of finished, but we have now formed some objects that are a little bit more massive than other objects. And because this plays out differently every single time, this is why some solar systems or some star systems ended up with binary stars, maybe even 3 or 4 stars, and some just ended up with 1. And you'll notice that these are the most massive ones right here, and they're slowly combined into larger and larger chunks. So let's just wait for it to kind of play out. Now, this is obviously not the best representation of what gas particles do, because there's just not enough of them, only 200. But on a much smaller scale, this is kind of what really happens. And here, we're just going to wait a little bit and see how all of this looks after maybe a few more in-game days. Now, I want to try this again afterwards with a little bit of maybe smaller objects, just so that they're not as massive as these. But even here, you can see that some objects, they basically just kind of fly away right away. And they'll probably come back later on, or maybe they'll combine with something else. But some kind of just stay in the middle. And so for the most part, the collapse itself occurs right here. So this is where a lot of the objects will actually start forming into first the star itself, and then planets and other objects in this particular star system. And if I actually remove the labels, you'll see that some of these objects are already pretty bright, and you can see there's something going on right there with a binary object. Some of them are still colliding, and on the other hand, if I enable orbits, you'll see how chaotic and crazy all of this is. There's a lot of interactivity here. A lot of things are still unsettled. And basically, this is kind of what happens in early solar systems as they essentially start their life with all of this gas slowly colliding into larger and larger chunks, until at some point one of them becomes a star, and then the whole process changes completely. So here, I don't really know. Oh, this might be actually a star soon, because it already is pretty massive. But I don't really know how long it will take. But it's very clear that this is an object that might become a star very soon. It's already kind of near that limit. So let's maybe take a look at some of the other potential candidates here, if there are any. And it looks like actually this is the most likely candidate. It's called Moon 172. The closest other object is this, and I think, yeah, their mass is a lot lower. But we could potentially end up with actually a binary or even a trinary system here. So let's just kind of wait a little bit longer. We're gonna maybe focus on this particular object for now, and wait a little longer until maybe something else collides with this. And as soon as this happens, this will most likely, oh, there we go. Just as soon as I said it. And look at that. So now this is a star. And this star will obviously repel some of the material from its vicinity, but it will also start attracting more and more mass because it's a lot more massive now. The objects that got to escape in the beginning, they'll actually most likely return now, because there's a lot of mass here. And as you can see, it's already absorbing more and more stuff. And within the next sort of few in-game days, it will most likely absorb a lot of this material, and the rest of the stuff will start slowly orbiting around this and possibly create planets, or at least planetesimals, the early planetary objects. So now you can see that it actually captured something. And what's interesting is that every simulation I ran always had an object that orbited very, very close to that particular star. Now, you may have seen the video I made about the so-called hot Jupiters. And what's interesting is that many star systems actually have these objects. They have these tremendously massive gas giants, about this mass, actually about 7 to maybe 10 masses of Jupiter, that orbit very, very close to these early stars. Our solar system doesn't seem to have any, but we think that it used to. And it's possible that maybe this is actually how all of this is formed in the beginning, when we just start with the newly formed solar system. So this particular system might actually have this young hot Jupiter that will stay here and eventually fall into the star. Just like that, just like you saw right now. And notice how now it has all these fragments flying around. And these fragments, we think, in our own solar system were created by a collision of several of these gas giants that eventually resulted in the formation of terrestrial planets. So our Earth and Mercury and Mars and Venus were actually most likely born from the collision of these large gas giants, or possibly Neptune-like objects. So this is kind of all really beautiful, and it ended up creating this almost perfect model of a solar system, early solar system. So you have this star in the middle that's maybe about a fifth of the mass of our own sun, and a lot of fragments, a lot of objects orbiting around it that will eventually create a functional star system. Now, all in all, I'm pretty happy with how this worked out, but if you want to try this yourself and want it to be a little bit maybe more realistic, what I would suggest is do the following. So start with a small object, so for example maybe Deimos here, place it in the middle and pause the time, then add rings to it. We're going to use Saturn rings here, and instead of bodies we're going to use particles. So let's say 200 particles. We're going to give them a much smaller mass, maybe approximately one mass of the moon. Give them some color so you can actually see them. I'm going to make this white. Place them, let's just say about 500 to 140,000 kilometers away. And also make sure that it's a box, randomly filled, and that has no speed. Place this and remove the central object. So now what we have is, if you zoom out, you'll see that these are actual particles. They're gas-like objects. Now, they're not actually going to move just yet, so we need to do something to them. We need to convert them to full bodies. And this now will actually start interacting with each other. And the thing is, it actually interacts a little bit more realistically because they don't produce any fragments, they don't actually create too many unpredictable collisions, but they do sort of interact in a way that gas would. And unfortunately, if you actually want to make this into a star, you'll need to give it a lot more mass. But because I'm currently not really running this on a very powerful computer, if I place more than 1,000 particles, my computer just kind of dies. But notice how right away they kind of collide all into one single point right there. So that's really one of the best ways of trying to simulate this formation of a solar system using gas collapse theory. Anyway, so hopefully you learned something about the formation of our solar system from this video, and now you know how our sun was actually formed back in the days. If you want to try this yourself, Universe Sandbox Square is one of the best simulations for this, and I believe you can actually get it for as low as $10, either using the link below or on Steam. Anyway, thank you so much for watching, guys. Subscribe if you still haven't. Share this video with someone who you think might enjoy learning about space and wants to learn about science using video games. And come back tomorrow to learn something else. Thank you so much for all your support. Space out, and as always, bye bye.